Hello everyone, I am Antonio Ayer and I am going to present some highlights of my research about the transition to modern mathematics in Spanish primary education. So this is the outline of the communication, the usual structure, and we are dealing with modern mathematics or a new math movement, which, as you know perfectly, was an international, a worldwide phenomenon that among other aspects, tried to bring school mathematics closer to academic mathematics. Its history has been an interesting and active research topic for the last 35 or 40 years, and we can find works providing a general overview of this phenomenon, but also providing detailed case studies about the implementation of modern mathematics in different countries. It's interesting to point out that even countries that did not attend to a well-known seminar, like Iceland, Portugal, or Spain, ended up implementing modern mathematics in their curricula. And in my case, I am particularly interested, of course, in the case of Spain. In my country, modern mathematics was fully implemented in 1970, but the first step that led to this full implementation were given in the decade of the 1960s, with a series of meetings addressed to secondary education teachers that were organized by the Ministry of Education, that would ultimately lead to the publication of official syllabus and textbooks for the first stage of secondary education in 1967. In the case of primary education, we are not aware of any official initiative of this kind, but in any case, some researchers like González Astudillo have identified the presence of papers published in professional journals addressed to primary education teachers in which modern mathematics topics were covered. And interestingly enough, the new primary education syllabus that was published in 1965, before the syllabus, the new syllabus for secondary education, already contained explicitly modern mathematics ideas. But in spite of being the first official document, official curricular document containing modern mathematics in Spain, doesn't seem to have explored from the point of view of history of mathematics education in Spain. Okay, in any case, in order to understand our research objectives and the design of the research, we need to provide some background. After the Spanish Civil War, which, as you know, took place between 1936 and 1939, we didn't have a lot of primary education until 1945, and we had no official syllabus until 1953. This 1945 law of primary education established that primary education was mandatory, at least on paper, for ages 6 to 12, but the truth was that many students quit school well before 12. Primary education was organized into 3 stages, as you can see there, and there was some kind of a strange overlap with secondary education, which started at age 10. Later on, since the situation greatly changed between 1945 and 1965, there was a reform that established that the whole 6 to 14 period was mandatory. 3 stages were unified, the overlap was removed, and we could say that the situation was modernized. So we have a change in 1965, which of course determines our objectives and our design. Our research question is related to the presence of modern mathematics in official documents before 1970. And in particular, we want to analyze this 1965 syllabus and compare it with the previous one from 1953. And in order to give a wider view of the situation, we will also compare textbooks published before and after the approval of this 1965 syllabus. And we will focus on this first stage of primary education, namely covering ages 6 to 10. From a theoretical point of view, we adopt Hammond's framework, which is useful to describe and to organize this kind of research related to curricular reform. And in fact, most of the research that has already been done about modern mathematics in Spain can be described in terms of this layer, and it's the same situation for us. Our first objective is related to this layer of curriculum, and our second objective is related to this layer of classroom concept. From a methodological point of view, we will adopt a qualitative approach. We will carry out a content analysis, and our sources are of documentary nature, and each objective has its own sources. In the case of objective 1, we will focus on official syllabi from 1953 and 1965. We will analyze both the methodological and didactical indications and the mathematical content. While in the case of the second objective, we have chosen the same textbook series published by the same company called SM, which was and still is one of the most important publishing houses of textbooks in Spain, and we will analyze the same series, as I say, published before on red 1965 and after. As you can see, as a curiosity, that the cover page of the textbooks already foreshadows the changes to be. Okay, now we can present some results. First of all, regarding the syllabi, and in the case of the introductory sections, we identify very different cognitive assumptions in both documents. In 1953, we find an explicit mention to the importance of repetition in order to acquire mechanical knowledge, while in 1965, the emphasis is not made on acquiring a mechanism, but rather on doing exercises as a pathway to understanding. And in this section, we already find modern mathematics ideas, both implicit. We can identify some kind of a structural view of mathematics, but also explicit, because topological and set theoretical concepts are explicitly used, and the language of geometric transformations is used, and so on. The situation is even more interesting in the case of mathematical topics, not at a microscopic level, because the contents are the same, elementary arithmetic and geometry and the metric system. But at a microscopic level, we can identify more interesting differences, not in the case of metric system, of course, but yes, in the case of geometry, for example, in 1953, much more attention was paid to geometry, and in particular to three-dimensional geometry, where many ideas were introduced much earlier in 1953 than in 1965, not only in the case of three-dimensional geometry, but also in the case of plane geometry. And some interesting special features of the 1965 syllabus regarding the presence of set theory. In 1965, we find set theory, at least the idea of set and belonging to a set, already in grade 1, but only in grade 1. Very brief mention of set theory, but we can identify also some modern mathematics ideas related to a structural view of mathematics, such as the explicit mention of commutative and associative properties, or the presentation of idea of base of number system, and so on. What happens if we move on to the case of textbooks? Well, we have different situations. In the case, for example, of metric system, as was the case with curriculum, we find no changes at all. If you compare these two pages, you will see that they are almost identical. Only you will see only some aesthetic changes. In the case of elementary arithmetic, for example, we find the introduction of new resources. For example, on your right, you will for sure identify the presence of Cuisenaire rods, which is absent on your left. The composition and decomposition of numbers, such as 4 is 3 plus 1 or 2 plus 2, was exemplified using dominoes instead of Cuisenaire rods. But of course, as one could imagine, the most important difference was to be found regarding the presence of set theory in the textbooks published before 1965. And even if we have seen that in the syllabi set theory was present only in grade 1, here we find set theory in grades 1, 2, 3, and 4, which an increasing importance. In grade 1, for example, we have only 4 pages, not at the beginning, where the elementary ideas of set, element, belonging were informally introduced. We find the idea also of one-to-one correspondence and somehow formal definition of number and comparison of sets using correspondences, as you can see there in the figure. In grade 2, the same ideas were visited, plus the idea of subset and equivalent sets, and the definition of natural number was refined or re-elaborated using this new terminology. In grade 3, the presence of set theory increased to 8 pages, and it introduced the brace notation, linear diagrams, the definition of unit set and empty set, and then again a re-elaboration of the definition of cardinal number. And finally, in grade 4, we find 12 pages with sets defined intentional and extensionally, the use of Venn diagrams, disjoint sets, formal definition of counting, and a naive idea of infinity, and more symbols and notations. So we have some comments to make regarding the presence of modern mathematics, the introduction of modern mathematics at this 1965 reform. In the case of curriculum, the ideas of modern mathematics were mostly present in the introductory section, with structural biomathematics, with the use of topological set theoretical concepts, language of geometric transformations. But set theory was present only in grade 1 and very briefly. Not a lot, not a great deal of modern mathematics in the curriculum, in the official curriculum, but it was there in essence. In the case of textbooks, it was different. It's interesting to point out that in fact textbooks did not reflect the official syllabus. They contained much more set theory than intended, and also, and in spite of this, some traditional topics were not abandoned. And we have identified a very interesting phenomenon, in my opinion, that is the fact that, okay, they contained quite a lot of set theory. I've seen 4 pages in grade 1, 4 in grade 2, 8 and 12 in grades 3 and 4. But this terminology was restricted to these chapters. Once they were introduced, then the language was never to be used again throughout the textbook. So they were, the chapters devoted to set theory were somehow independent from the rest of the textbook. This was not the case later on in 1970, where the language and the terminology of set theory was spread throughout all the textbooks. But in this moment of time, these first textbooks, including set theory, did it in a rather independent way. And of course, this spurs some further work. First of all, we would like to integrate our findings with the previous work about modern mathematics in Spain. In particular, it would be interesting to relate with the previous work on modern mathematics in primary education, and in particular with this work, the presence on pedagogical journals, on professional journals, will be an interesting line of research. And then, of course, and since we have identified a lot of set theory in our textbooks, and I would say that it was more than in other countries, and if not more, earlier. I think it would be interesting to compare this situation with the situation in different countries regarding the presence of set theory in textbooks. And well, this is a short list of the references that were mentioned in the presentation, and this is pretty much it. Thank you very much for your attention. 谢谢。